Assalamu alaikum viewers. So today we are going to solve question 3 of March 18 paper 1-2 AS physics paper. So let's begin. Two forces of equal magnitude are represented by two coplanar vectors. One is directed towards the east and the other is directed towards the north. What is the direction of a single force? Don't forget, they are asking about a single force that will balance these two forces. They are asking about a single force that could balance these two forces. So now let's look at the working. So I have made this diagram for you. Now it says that the one force is directed toward the east. One force is towards the east, right? And then they say that the other force is directed towards the north. So the other force is directed towards the north. And what do they need? They need a single force. They need a single force that balances these two forces. Now, first of all, you must be thinking that how could there be a single force that would balance the two forces? So the answer is very easy. See, first of all, what do you have to do? You simply find the resultant force of these two forces. Okay. Now, how would you find the resultant force? They are not connected head to tail, right? So yeah, there are two ways. You must have learned these two ways in your O levels. These are triangular law and parallelogram law. First, I would explain you the triangular law, then the parallelogram law. In triangular law, the two forces for which you are looking for the resultant force, you must connect them head to tail. So this is one vector. This is the vector that points in the east direction. And now I'm connecting the other vector to its head, other vector's tail to its head, which is pointing in the north direction. Okay. Now you must have learned that the resultant force joins the tail of the first vector and the head of the last vector. So its direction would be like this. Okay, don't forget this direction. Now let's look at the parallelogram law. Now, as you know that the parallelogram has two pairs of parallel sides, right? So if this is, now they would have the same direction. So I'm going to draw two more sides which are parallel to these. This may not look as the perfect parallelogram. You must be seeing it as a square, but like the name of the law is parallelogram law. I couldn't draw it here like that, but assume that it's a parallelogram, okay? So it would have the same direction here like this, as the vector pointing towards the east, and this one would have the same direction as the vector pointing towards the north. Okay, so now you have to find, now you will have to again connect head to tail. Now you can see it automatically connected head to tail. The head of this vector is connected to the tail of the other vector, right? Now you have to draw a resultant force from the tail of the first vector to the head of the last vector. So its direction would be like this. As you can see that both ways gave you the direction of the resultant force to be the same, right? Now they say that now this is not the answer, okay? Don't think that this is the answer. They say that you must find a single force that balances these two forces. Now we have found the resultant force of these two forces. Now, of course, if this force is pointing in this direction, so the force of equal magnitude must point in the opposite direction to balance it, right? So now this is the arrow which shows us that single force which balances these two forces. And now for finding this direction, you just need to look at the quadrant in which it lies. It lies in the south and west. So it is southwest, towards southwest. Now let's check if there's any options like that. Let me see. Yeah, the option D says towards the southwest. And what we discovered, yes, it was southwest. So option D is the correct answer. And thank you so much for watching. I hope you like the content of this video. So please like, share, and subscribe. And if you have any question, you may ask in the comment section below. Thank you so much.